Sorry, we're in the middle of notes. I forgot to start recording. So the first thing we're going to do is write the cosine of 2 theta identity that has sine in it only. Okay, that's what we did in the book. You cool? The second thing we did is then we replaced theta and 2 theta with a and half a. Yeah? Now, we want to develop an identity for sine of half of an angle. So we're going to solve for the sine of a over 2 to get it by itself. So here we go. What's the first thing you want to do to get this guy by itself? Move over the 1. Cosine of a minus 1 equals negative 2 sine squared of a over 2. Then what?
Divide by 2.
Divide by 2 or negative 2?
Negative 2.
Negative 2. Divide by negative 2. Cosine of a minus 1 over negative 2 equals sine squared of a over 2. We're so close. Okay? How do you get now? No, we're not solving for a. We're solving for sine of a over 2. The sign stays. Don't want to know. What do I want to know? The square root. Okay? So why won't this go down? Okay. So if I square root, I get sine of a over 2 is, now when you square root, what do you got to do?
Don't you have to square root the entire side, so don't you have to square root the a and the 2?
Now that's, no, so this is, this is really what that is written. And so when you're square rooting, everything is, I am square root. That's a good call though, I'm glad you're paying attention. So plus or minus the square root of cosine of a. Now I'm going to do, actually I'll do it in a second. Now I have the sine of a over 2 in there, and the typical form that I want you to write in the box is instead of those 3 terms having 2 of them negative, the more common is if you multiply top and bottom by -1, the common form is plus or minus 1 minus cosine of a over 2, so you only have 1 negative instead of the 2. Yeah. Okay. The 2, make sure this root extends all the way down so it's not confusing as to whether the 2 is in there. I don't want you writing it like this. It's the root is all over all. You down? Are you with me?
Yes.
Okay, cool. Then, with that in mind, how do you reckon we do cosine of theta over 2? So over here we started with the cosine of 2 theta identity that had sine only in it. Well here, you'll start with the cosine identity that only has cosine in it. 2 cosine, cosine of 2 theta is 2 cosine squared theta minus 1. Very cool. Now after that we substituted in with, instead of the angle and its double relationship, we went more like a half and the whole. So what does 2 theta become? You can look at that same picture. A, it's cosine of A. And what about theta? A divided by 2. Everything else is the same. Okay? We're trying to get an identity for cosine of theta over 2, or a over 2. Don't worry about the theta or the a, just solve for the half angle. You with me?
Yes, sir.
Okay, so what should we do?
Divide by 2.
Not yet.
Move the
Add 1
move
first.
1 over and then
Add 1, divide by 2. Let's do that in 2 steps
I
this
think we
time.
can.
Okay? Now what?
Square root.
Square root, and when you square root, it's
Plus or minus.
plus or minus. Now, the hard part is it looks almost identical. What's the only difference to the one above? It's adding instead of subtracting. Otherwise, they are exactly the same. And that's important, that little distinction. Okay? And then tangent of theta over 2. So we have two choices to develop this. We could either go the tangent 2 theta and replace 2 theta with half and whole, or we could do sine over cosine. Okay, so let's say we do sine over cosine. Sine of theta over 2 over cosine theta over 2. Sine is 1 minus cosine of A all over 2 divided by 1 plus cosine of A all over 2. Let's do a little bit of cleanup on that, shall we? What about the, what?
Why did you square root this?
We were solving for cosine of A over 2, not cosine squared, so they have square roots to get rid of the square. Okay, so from here to here, you had to square root to get cosine of A over 2 by itself. Okay, so now, let's clear the 2's. Can I multiply top and bottom by something? 2?
No. Square.
No.
Square.
Root 2. Root
2.
2. Okay, when you do that, the top, let's just combine it into one big plus or minus. We don't need to.
Oh boy.
And what is,
Plus? Oh,
it's plus or minus, what you're talking about. Okay, so the top is 1 minus cosine of A over 1 plus cosine of A, yay?
Yes, sir.
Now, the last thing is we probably want to make this a little more,
accessible.
yes, okay, so let's make it a little tangenty, shall we? How do we make it tangenty?
We would divide by sine. Wait, divide. Multiply by 1 over.
1 over cosine. Okay, now if you do that, then when you distribute to the 1, cosine?
What?
Yeah, how are we going to get tangent out of this?
That's why I said oh wait, sine is.
Should we multiply, divide by sine?
Tangent just is plus or minus 1?
So tangent would be sines over cosines, do you agree?
Yeah.
So how do we get sines over cosines going on?
Mr. Rickman.
Yep.
I don't think you're supposed to do
Yes.
The first step isn't it sine?
No, because.
I don't think you're
Okay,
supposed to start.
so first of all, let's go back here. Do you agree that tangent is sine over cosine?
Yes, sir.
Okay, so we're all good so far. Okay, do you agree that we just found that sine of theta over 2 is cosine, 1 minus cosine over 2? Okay, cosine. And that cosine of theta over 2 is 1 plus cosine. So you're good on step 2.
It's negative. Wait, why is there a cosine?
It's a negative right there.
Wait, go back. No, if sine is negative 2 on the bottom.
Look at the cleaned up version right here. please. We wrote that as a cleaner version, like that, okay? All right, are you with me?
Uh-huh.
Okay, so we are at 1 minus cosine of, do you agree with the two identities there? Were you okay there? Were you okay with clearing the 2's?
Yes, sir.
Okay, so you're good up to this point. That's where we're at now. Are you with me? Okay. Now, this is the part that we are, actually, before we move on, we're all together now?
Yes, sir.
All right, so now we're trying to make this a tangent identity that actually has tangents in it. So now we're at the point we're trying to figure out. So if we multiply by cosine, yeah. So what about multiplying
Cosine squared is 1 minus
1 minus sine squared?
Yeah.
So you're saying multiply top and bottom by cosine?
Yeah.
That makes this cosine squared, but that's cosine minus cosine. That doesn't get anywhere, yeah?
So I think it's fun.
You think
Well,
so?
it's plus and minus.
Tangent in place of, that's fine. The problem is that it's not in tangent, okay? The problem is that we have cosine, it's not tangent. We should have a tangent identity that's about tangent, not cosine.
The sine is not multiply by sine over
Yeah,
cosine.
sine isn't cosine.
True, that's a good point. So shall we, you wanna leave it?
Everything isn't
Like
cosine.
you can
Okay.
multiply sine over cosine and then be sine minus, wait, no.
Yeah, let's just leave it in terms of cosine. You're right, it is consistent. They're all in terms of cosine. So I'll leave it by that form, and if it needs to be cleaned up later, we'll talk about it. Let's do an actual numerical problem so you can get a feel for what this looks like, okay? So, sine of 75 degrees.
Okay.
You're going to want to read carefully, first of all, because now you have two ways to do this problem. One is a sum identity. If it said sum, then you could do sine of 75 is sine of 45 plus 30. However, it doesn't say use a sum identity. It clearly says use a
Half what?
half angle identity. Are you with me? Okay? So I know that sine of
You're doing great.
a over 2 is plus or minus 1 minus cosine of a over 2 from above, right? Helps to have that down in front of you so you know what goes where. Now, if that's the case, you write down the formula, if you will, the general identity. Thank you. If you write down the general identity, then you can tell exactly what A needs to be. If A over 2 is 75, write it down. If A over 2 is 75, then A is
2 times
150, okay? So that implies the sine of 75 is plus or minus 1 minus the cosine of 150 over 2. Now we're going to simplify. When simplifying, you're going to need to choose plus or minus based on 75 degrees. I know that sine of 75 degrees is in the first quadrant. I should choose plus, okay? Whereas other angles you might choose negative. So I'm going to say it's definitely plus. No more plus or minus. For this problem, it must be positive. Then I'm also going to simplify the cosine. What is the cosine of 150? Negative root 3 over 2. So 1 minus negative root 3 over 2 over 2. Let's do a little bit of cleanup. Okay, so what could you multiply top and bottom by to clear the fractions of it? 2. If you multiply by 2 over 2, then you get 1 plus,
No, wouldn't you have to multiply the numerator?
or sorry, 2
by
plus,
1 over 2?
excuse me. What?
Does it have to be root 2?
No, no, 2's fine.
I'm going to multiply by 2 to clear out that 2.
Oh.
Wouldn't you want to do by
Now, when I do that 2, I get 2 plus root 3 over minus negative, yeah. Minus 4. Do you agree? Hey,
Wait, that's gonna get imaginary.
it is not a imaginary number. Everything is positive. All right. So now, last but not least, a little bit more cleanup. Now the top is hideous. It's a root within a root, and that is what it is. But the bottom, we can actually square root 4. It is 2. That is our
That's our answer.
final answer.
Don't they all do that?
They will look like that almost always, all right? Cosine of 195. So start by writing the identity. I said the first thing you do is write the general identity down. the cosine of a over 2, or theta over 2, whatever you want to call it, is plus or minus the square root of 1 plus cosine of a over 2. Then we're going to figure out, all right, for this problem, what's a over 2, what's going on here? A over 2 is 195. So a is 390, which is the same as 30. All right? The cosine of 195 then is plus or minus 1 plus cosine of 390, or 30, divided by 2. Just plugging stuff in. Now we're going to choose plus or minus. Cosine of 195. What quadrant is cosine of 195 in? Third. Is cosine positive or negative? Negative. So we're going to say it's negative square root of, what is the cosine of 30? Root 3 over 2 over 2. Let's clear the fractions, multiplying top and bottom by 2 over 2, so it becomes negative root 2 plus root 3 over 4. What do we do to finish? Negative 2 plus root 3 over a clean square root in the bottom of 2. Okay. Do you follow me? Okay. For problem 6 through 8, I'm giving you some basics about what alpha looks like and what beta looks like. We've done a million of these. Draw it first. Go over to the first, or the box, and draw me a triangle. What quadrant should alpha be? Third or fourth, because sine is negative, but then they say alpha is between negative pi over 2 and pi over 2, so it must be fourth. So let's go through the logic again. Sine negative implies what two quadrants? Third and fourth, okay? This implies which quadrant? Negative pi over 2 to pi over 2 must be, okay? For it to be negative and between negative pi over 2 to pi over 2, it's got to be the case that we have a fourth quadrant triangle. Please do that slowly. Everything over there will be a total waste of time if your picture is wrong. So, get the picture right. What about the sides then? What goes where? Negative 4 is opposite. 5 is hypotenuse. Is the adjacent 3 or negative 3? Positive 3. All right. That's minus. Yeah. Okay. This is alpha. Beta. This tells me that beta must be what? Two quadrants. Cosine is negative where x is negative or y is negative. Cosine is x is negative in second and third. It's got to be second and third because cosine is negative. But they say sine is positive. So is it second or third? Second. Draw a triangle in the second. Now put some sides down. Negative 5 is the adjacent side, yay? 13 is the hypotenuse. What's the missing side? 12. That's the Pythagorean triple. Now we have the pictures. Now we can go and do the problem. Cosine of alpha plus beta, that's review. Do that first on your own. you get 33 over 65.
Yes, sir.
Okay, so you should have started with the identity for cosine sums. Use the picture to replace all four trig expressions. Give you a second to check your work. If you didn't get that answer, then check your four trig pieces. They should match mine. Let me know when you're ready to move on. Okay. All right. Now, let's try the new stuff. If I gave you that picture of beta, we're going to look at the beta picture here. They say beta over 2. Okay, we need to start with the identity. Cosine of beta over 2 is plus or minus the square root of. Okay, cool. Now, based on the fact, ooh, this is rough, all right? Choosing the plus or minus, what would b over 2 be? What quadrant? Where would beta over 2 be? Would it be positive or negative cosine?
Well,
Positive.
Why?
The angle's like 100 something.
Yeah, if this is a full beta, then wouldn't a beta have to put it in the first quadrant? You with me? Okay? If you take half of this angle, even if it was 179 degrees, what would half of it? 89.5. Half of it has to be in the first quadrant. And so the sign must be positive. Okay? Now, 1 plus, what is cosine of beta?
negative 5/13.
Negative 5/13 all over 2. What should we do for some cleanup action?
Multiply by 13.
Multiply top and bottom by 13. The numerator becomes
Root 13 minus 5.
13 minus 5 over 26. That is
8 over 26.
8 over 26 or 2 root 2 over root 26. I don't know if they're going to, they clean their roots up in the book, don't they?
Yeah.
So if you multiply top and bottom by root 26, you get,
Do we have to?
yeah, let's do
2
it.
root 52.
2 root 52 over 26. So root 52, this simplifies a lot, doesn't it? Gosh,
Yes, it does.
I probably was not very efficient. Can we go back here and let's do this smart? Let's reduce this first. Isn't this root 4 over 13?
Yes.
Okay, so that's 2 over root 13. So what's your final answer rationalized?
2 root 13 over
2 root 13 over 13. We should have reduced it first to make our life easy. All right, are you with me? All right, on your scratch paper here. 2 minutes?
Yeah, because we spent so long.
Wow, this is not gonna probably go happen in 2 minutes. All right, well then, at any rate, your homework, I guess we don't have time for it. No, it's in the
Oh,
test.
second is such a dyslexia scare, like.
So your test is tomorrow. If you did badly on the last test, you want to review, come in and review. And I'll be happy to help you. What? Yes.
I mean, it could be a very frustrating. Well, she went to be like on the Navy.
All right.
It is like really hard to get a job. You do that, like,
Are there actual options?